The heat and the noise have apparently been fixed. Yes. There's not the buzzing noise. It's not. No, it's just in your head. Okay, if anyone leaves the building and the noise is still in their head, please proceed directly to health services. Okay? All right, so we want to do number 49 and 10.2. And all of this is on the video. All right, so how do I do this?
Notice that x squared and y squared. You have to factor.
Okay, I should factor this thing, and then I should notice some squares that kind of are undone, right? Okay, so, oh, wait, the noise is back?
I know.
Okay. Well, at least the heat's back. All right, so what can you factor this left thing into? What would you hope for?
X plus y squared plus y squared.
Yeah, you'd hope for it to be a square, right? So is it x plus y squared?
Yes.
Yeah? Okay. And then we've got minus
X minus y.
Okay, why aren't you having to do absolute values?
Okay, absolute values. It's not necessary.
Yeah, these should be absolute values, right? But the book says not to worry about it. You guys see that? Okay, so I'm not worried about it, but normally I would put absolute values here, right? Because squaring and square rooting don't actually undo one another. They just close to undo one another. How about this thing? What can I replace that stuff with?
Square root of the square.
Okay, that should be x plus y
Minus
x minus y.
That would be 0.
Gives you a grand total of nothing. Okay, cool. This is apparently another way to write 0. What's up, Carl?
Can you do like the little step there between the top part and the x plus y squared?
This guy?
Yeah,
Yeah, really
just
that's
factor
me
it out.
just looking at this thing and thinking
Okay, and you can get
to myself.
Okay.
Oh, okay.
Now it makes sense.
Another thing you could do is you could run the AC factor method on that thing. Do you want to see that?
Yeah,
Or?
can you do that to that?
Okay.
Do the math.
So if I maybe didn't see that I could factor that into I might think, all right, I'm going to just AC factor x squared plus 2xy plus y squared. Oops, new twos.
Yeah, he's sneaky, he skips steps.
Okay. So yeah, I'm looking for two numbers, right? Two numbers. Multiply to 1 and add to 2. Okay, so what multiplies to 1 and adds to 2? 1 and 1. Okay, so that means I'm going to take my 2xy and replace it with xy plus xy. Okay, then what?
Factor by grouping.
Yeah, factor by grouping. So out of these two, I can get an x, and I'm left with a x plus y. And here I can factor out a y, and I'm left with a x plus y. And then now I'm counting x plus y's, right? So if you have x of something and then y more come along, how many you got total? X plus y. So there's x plus y of the x plus y's. So I'm hopeful that at this point you see the perfect square trinomial.
Yeah.
If you don't, try to AC factor it. There's a little psychology here too, right? The psychology of looking at this says, gosh, I really hope that this thing under the square root is something squared, so I can cancel the square root and the square, right? You see that? If they hadn't told me to assume that everything was restricted to values where I could not worry about absolute values, where would the absolute value bars go in this piece? You see that?
Around x plus y.
Yeah, it would be around the whole x plus y. So if I was to do this with absolute values, I would really get
Yeah.
this. right? I'd get the absolute value of x plus y minus the absolute value of x minus the absolute value of y. And this thing is not 0. You guys all see that? So if one of my variables, x or y, were negative, then I wouldn't be able to write this step, right? I'd have to go to absolute values, and then it wouldn't be 0. Let's go with that. So we're getting a little bit lucky, right, because of the extra direction.
Can we do 50 also?
Yeah, let's do 50.